Hello friends, so today we will create a Apple counter. Let me show you what will you will learn. So this is a video, small video, means you can see the output video of after the project. You can see how well it is counting the apple. So let me show you what all things which you will learn. Okay, things which you will learn is that how to create a custom dataset using Roboflow, how to properly annotate objects or better model accuracy, how to convert one annotation image into the full data set, and how to use the data augmentation, how to train your own custom model, how to download dataset from the download the model from the Google Colab, YOLO tracking, and ROI reasons, draw custom reasons and counting lines, line crossings. This all things which you will learn means 28 things you will learn from this whole video. This is a whole project from end to end. Okay, uh, so let's get started. I will explain each and everything. So this is a frame zero, means you can say first frame of the video. Then I go to the Google Drive. Okay, let me close it and let me just delete this projects because I have already created it, so it's not required right now. I from from start I will explain you from beginner to make it beginner friendly. So for that, now go to type here Roboflow. You will get it. You will go to annotate, then sign in. I already created the account, so it directly jumped to my home page. Okay, so go to the project, new project. My project name will be Apple. It should be Apple. Then make sure that you can it is public, and make sure that the project type will be object detection. Then create public project. After that, you have to upload your image which you have extracted from the video. Then save and continue. It will upload the file. Wait for the second. Okay, then label myself, then start annotating. Okay, then select this tool, bounding box tool, then just draw a bounding box here. Okay, done. Then object will be a apple will be, this is object class name. Then save excel. Now I do not require to label every apple one by ones. I just use one tool here which is Roboflow provided. Just go to here. It will automatically detect all apple in that particular image. Yes, approve 53 apple. Done. Then just cross it. After done, just you have to go to here. Yes, add one image. Okay, it's done. Now just go to the, you can say first you have to see the classes and text. You can say two classes is there, object and apple, but we do not need object class. So how we can do that? Just use modify classes, sorry. Then go to apple, click here. Okay, so click here, done. Continue. We have to delete this object class, so delete it. Yes, confirm changes. Done. And then version, and then continue, and just create it. This way you will get your data set, means you first a single image. Then you have to download a data set. In which format? YOLO V8 format. I want to download it in zip file. Okay, then just continue. Okay, here's zip file. Will download it. See here. Now let me okay, let me open my download. Then go to my this part. You will get train data. This is all data which you want. So first of all, I just want all this for. Let me just copy it here from here and go to my here Apple counter. Now I want to explain from beginning. So let me delete my Apple data set. Okay, I want to delete. So let me delete it. It had deleted. Now I just create a new folder. Okay, its name will be. Let me do it. Should be
data sets. Okay, this is a folder name. Inside the folder name, I will paste all those files which I have copied. Okay, I think I have to again go to this. Just selected the C, Control plus C, then again go to the folder where it is in model, and then just paste it. Okay, all thing is done. You can see we have only single image, and you can say size will be 512 size. Then labels, according to size only this label will be generated. Now let me one thing, they let me change one thing here. It should be frame 0, and same way go to label and change the name. It should be frame 0. Done. Go to come down, we have to check the annotation, that particular annotation is perfect or not. Just uh, these are the libraries which is required. Okay, so first of all let me wait for seconds. Done. The cell is running. Second time, please wait. It's done. Now image path and you can say label path. Here we are plotting the two images, but right now just one, I want a single plotation. So just how we are doing it, you can say I want to plot two images. So here first row, two column means two images, figure size will be 20 and 16. For that plotation, we use plot the subplots. Here figure basically present this entire subplot, and x is just for the iteration over the subplots. Here x ax dot initially in this line, it is in 2D format. When you will x dot label, it is a 1D format. After that, beyond we have to plot two images. So I will loop for loop for two times. Okay, so then OLS directory means image path. It will list all the images present in a particular directory. After that, it will randomly choose image name or randomly choice. After that, I want to go and want to know image path. So what is how we can get it? Just use with path joint and image path means this part, and then the file name which is selected randomly, it will give me this thing. Now I want to get the label path, and you will know that this Apple dataset in train label frame 0 and image 0 both have same, but last four character will be different, last three character jpg and txt. So how we can do that? Just label path will be same, but last character will be image file name. -4 means extra dot jpg is not included here, but instead of that use dot txt. So this way we get the label path means label path name first, then after that we will read that image and convert that into RGB. After that, I will want to know the image height and width. So I done it. Now let me go to here. See, this is, you can see these are the coordinates values. So where we are here checking annotation, then we will open that label path in read mode, and everything will be which is stored in this where it is, where everything which is stored in this in all this will store in this f variable. After that we loop over the f variable line by line, we will read it. The line dot strip dot split will give me data a single line. Let me talk about single line. If I am talking about this uh, first single line, zero index value, then the accent, because we have downloaded a dataset in YOLO v8, means first coordinate will be x center, y center, width and height. So everything which is just after using that particular line data dot strip dot split data in data, it make the list of all this, and all this is in a string format. After that, how I can get a class id, just use data 0 and class id, it will give you class id. How will extract an x center? You can see all these values, you can see all these values are unnormalized form, and we have to unnormalize them according to our width and height. So how we can do that? Just uh, data one give me the x center, I and want on the float type. After that we will multiply it with width. Same way for the y center, x w width and height width. But we want x1 y1 x2 y2. How we can do that? Just you have for that purpose, just x center minus width box, then first width box will be divided by 2, then after get the x center, you will get x1. Same way for the y1, x2 and y2. If you got confused at how this calculation is going on, so you have to again and again, means hit and trial method, change the width, change the height, change the box, or change something, means you have to do hit and right rebel, and you will ultimately know how this calculation going on. Once you understand this calculation, you will not forget it. Okay, so that's why you have to do hit and right trial method. Okay, then see, we will plot a rectangle and just show. Now let me show you. Okay, Apple dataset, label train images by it's showing me two images. It randomly selecting same images at okay, so that's why. See, flotation is good. Annotation file is good. Now this is check annotation is completed. Now we have to generate thousands images. Now let me close other tabs which is not required. Check annotation is completed. Yes, save it. Then frame 0 not required. Yes, this file is also not required now, just for the explanation purpose. This is not required right now. Okay, so the thing is completed. Now we have to generate 1,000 images from using the single images. So how we can do that? Just image path means frame0.wg. The label path means this is, you can say, first image which we have downloaded. Now output directory, in which directory we have to upload this 1,000 images. For that you have to give that directory and that label. After that we will read that particular image. After that we extract height and width, and after that we will read that particular line. Okay, read that particular line and means particular label path. After that we will make two lists, boxes and classes. After making the list of boxes and classes empty list, we will loop over the YOLO data, means this line by line. After that we will map line split. This method where is check it. Yes sir, see, this is just explanation purpose. I have just expand the things, and for explanation I have explained all these things. But here you can say in single line it's all thing is happening. Okay, float then means convert that all things in a float, then line dot split, then mapped it with the class id x w width and height. So okay, this is happening here. Then we append this class as classes to boxes, classes list, and boxes to boxes list. Okay, so this way we get it. Here the okay, x center by center, box width and box height, all things is appended to this list. After that, this is data augmentation which we apply on a single image. A compose, horizontal flip, vertical flip, all this is, and this is a parameter for those. Okay, after that we will this is transformation. Then we will use this. If for I in range number images, how many number of images which we want to generate? 1,000 images. It will iterate 1,000 times. Then appended means augmented. We apply that particular transformation on which image with bounding boxes and category class id with classes. This way it give me augmented image. After getting the augmented image, I want this you can say how I extract the augmented image from this augmented variable. This is just easy. This is augmented image, and this is boxes, augmenting boxes, all things which I needed, I extracted it. Image name and text names should be same, and also it should be different from which is previous image name and file name. So how we can do that? Just use frame I plus 1 initially. Okay, because 0 is there and I plus 1 will be 1 started from 1 or 2. Okay, so it will be I plus 1 dot jpg dot txt. After that we will I am means I am write this image to the path of this. What is a path? os.path join out directory. Then out directory in image means this directory, and after that we will image name which we have created, and just pass the augmented image, and this way we get the image. Now we have to pass the label also. So how we can do that? We will open label and txt name which we created. This way we open the txt file in write mode and sf. Then we will iterate over this classes and augmenting boxes. Okay, I will iterate over this classes and augmented boxes. Okay, so this where it is, this classes. Okay, this classes list which we have created, we opened it zip over the same time. After that we will write a class as a first, you can say, first correct first string. After that will be put every single space with the when we print the box in a string format putting in, and after that we apply the new line. So this way we make a txt file, and this way everything is going on. Here 600 is not 1000 images will be there, but right now I want to say that you can plot 600 images. It's enough for training. Okay, so let's get started. Let me run it now. Let me first save it. Okay, for better, where it is input video labels, close it, go to here, Apple counter, common video. Oh, no, 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 this not, no, Apple counter, model, Apple dataset. You can see that the images are not there, and you can say labels are not there. Now let me run this file, save it. Now let me run it. Hopeful no error will come. It's taking a time, please wait. Oh, what's the error? Object has no attribute shape, means image is not loaded, or you can say image name is not correct. So the problem is that we can say our root directory is Apple counter. So here for reading the images, we have to use the relative image. Oh, sorry, not relative path we have to use. Okay, so that's why I have to give the full path model than this. Okay, here model than here. Okay, so this way you have to use a you can say relative path if your root directory is outside the folder. Okay, so let's get started. Now let me save it, then run it. See, now it's working. Okay, wait for the second. Again problem, what's the problem? Oh, sorry, here it is, this one. And I have to delete this file here because right now it will throw error. Okay, so let's get started again. Now it's worked perfectly. Yes, it's now working perfectly. Let me do it. Let me do it. Yes. Now, now you can see the images are coming in. You can say, and each images are different from the previous one. Okay. So this way it creates 600 images. Okay. Right now it's creating continuously. As soon as it stop. So it's completed all labels. Okay, done. So now go to see it's generated images. Check annotations. Okay, let me run it here again and run it here again and just plotation. Okay, see it's working. Now let me plot. It's working very well. Now let me plot one image. I want to plot 16 images. For that, 4 rows, 4 column. Now let me run it again. 2. Why? Let me check. Apple dataset. This one. And inside that we have images. Yes, labels. Yes. So to again use it. Let me run it again and then again here. It has to plot 16 images. Oh, sorry, we are looping six, not 2 time only. That's why 16, 16. Here 16 will come. This is a problem. Now let me run it again. Now it's a plot 16 images. See, 16 images is plotted and each image is different from each other. Okay. So this way you have created your data set. Now you have to just make the zip file of your data set and upload your data set in a Google Drive like this. Okay, like this thing. So I just copy the share link after that and just paste it. I already uploaded training Jupyter file in the Google Colab. So just copy this share link here and just keep this part. Okay, let me do it for you. Just keep let me erase extra part. Okay, so this part is not required.
Okay, till here. Let me comment. And this part is not required. Okay, so this part is important. Okay, till this. Now, after that, you have to give the output file name, the data set, this file name, Apple dataset, this file name you have to give. Just run it. Your dataset will get downloaded. First, it will connect with your GPU. Then, after that, we have to unzip it. Okay, so let me show you. We are using YOLO model, so we have to install the Ultralytics. Okay, so this is your dataset. Okay, with the two folders which you have created. Okay, then you have to train that model, the model which we are using YOLO 11 and the epochs will be 50, but right now I just wanted to do it for the two epochs because I already have the model which trained on 10 to 50 epochs. Okay, so just for the explanation purpose I am doing it. So first we load the model, then this is your data file name, means this data.yml file name, then batch, then epochs, then image size 640, batch will be 8, and save true, yes, you want to save the weight file. Patience 20 means after every 20 epoch it will see that there is an improvement in the training or not. If there is no improvement, then it will stop the training. Save period -1, yes, means that we do not want to save every epoch weight file, we just want to save the best epoch best epoch weight file. Validation true, yes, we want to validate also, but we do not have a validation folder, so it's used training images only for the validation purpose. Okay, so let me run it. And this is a checking of the images. What's the problem? YOLO is not defined, I think so. Oh, I forgot this cell to run. Then again, run it. Then you can see your run folder will get created here. Just wait for it. Then after that, this is where you can say loading of the model, which is still in a custom data set, how you can load it. Run folder will create it. Inside a run folder, you will get a detect folder. Inside a detect folder, okay, what's the problem? Dataset Apple dataset data images not found, missing path content Apple dataset valid images. Okay, I know the problem. So go to the data.yml file and see that your validation is having a validation for validation valid dot images, but we do not have a valid folder. So what we do it, we just have to erase this and just keep train here. Means for the validation use train images. Then just save it and close it. Now then again you will run it. There is will be no error. Okay, see. Inside run folder, detect folder will be there. Inside detect folder, right now I have run this cell 2 times. Okay, initially it was YOLO problem, but second time we have run it, but that problem is a bit due to the YML file. So it's first folder is this one, but when I ran second time it gave me 112. So 112 is a, you can say, the main directory where our weight file will be right now will be display. Okay, will be store. Okay, then how we can load it? Right now it is not 1.5, it is 1.2. Then weights, inside the weight folder you will get a batch.pp. This way you can load the model which is shown in a custom data set. Then this is your test image directory. How many plotation I want? 4 plotation, 16 plotations, so 4 rows. Sorry, 8 plotations, so 4 rows and 2 column. Figure size will be 15 by 16, and figure B will representing the entire plotation. X will be the iteration over the subplots. Here is in 2D format. In this line it is in a 2D format AX, but here AX dot rebel basically convert that into 1D format. 1D format, and we have to plot range means 4 to 8 times 8 plotation, so that's why I will range 8 times. Then I will first list all the images will present that particular directory in a test directory. Then I will randomly select one image file. How we can generate the image path? Just use os.path.join, then image path. This one, then the image file name which we will select randomly. This will be created image path. After that we will read that image. Then after reading that image we will pass that image into the result to the model, and zero index value because we are just passing a single image, so that's why zero index value to retrieve the result of that particular image. After that we just use 4 box in result.boxes to retrieve the bounding box details. So how we can do that? Just use box.x by format. We want a coordinates value dot cpu, the numpy we have to convert that into numpy format because those in a tensor format, that's why s type into, then rectangle, we just draw the rectangle. After that we will just convert that image into vgr to rgb because we are reading that image into cb2 by cb2, so it's able to read image in VGA format, so we have to convert it into RGB. After that we have to show that image. So this is a result of that. Okay, so I think so two epochs is currently take 2 times, but we have already have a, you can say, weight file. This is the best.ppt, which is trained on 50 epochs, so we do not require it. After training it, after training, you just have to download the weight file from here. Okay, let me complete one epoch will complete. You will see the best.ppt weight file and last.vt dot weight file. So wait for it, let me show you. uh, it's taking time for the here validation is going on. Okay, wait for the seconds. It's taking time. 75, 76, 81, 83, 87, 90, 92, 95, 97, 98. Okay, done. So you can see the last.pt and the vs.ppt also will be here. So don't worry. Let me refresh it. Or okay, let me open the, see the vs.ppt. You can download this weight file here. You can get a weight file, but you have to increase the epoch, because right now, just for the explanation purpose, I use 2 epoch, but if for your, you have to use the 50 epoch. Okay, for better accuracy. Now just go to the code again. So after that, you have to just download the weight file. Everything is done in model folder. Everything is done. We have created a data set. We have, after we have making the zip file, we have checking the annotation file. Frame 0 is used. Okay, so frame by we have created this frame 0. Now image generating is done. Training of the done. Everything is done in the model folder. But best we have done. We have reached the means we have retrieved the weight file. Now the main thing will come to here. Main.py means how we count the apples in particular video. How we can count the images in a particular video, and the video is this one. Okay, input video is this one, from where we have retrieved the, you can say generate the data set. So I will explain this whole code line by line, so don't worry. So let me explain you this main.py file. I have commented the extra code. So let me explain you. So this is a library which we required. Ultralytics YOLO to load the model, the model which we have downloaded. Then the CPU is required, NumPy is required, and from collection import we require the default and DQ. I will explain you what is the use of this, but right now just you can see these are the libraries which are important to import. So how we can load it? Just use YOLO, then give the path of the model which you have. Then how you can load the video for reading the frame of the video. You just have to use cp2 dot video capture, then path of the video, it will give me the cap. Then after that, we have to read the video frame by frame. For that we have to use a while loop. Before that, let me explain to this is ROI points. What is use of this ROI points? So let me show you one image. So this is output of the die. So ROI points is just a blue region points. So this is the first coordinate, second coordinate, third coordinate, fourth coordinate. I retrieve this coordinates values from the paint software. You can do that. So this is the coordinates values. Okay, this is the line points. Okay, it's a starting point, uh, first coordinates and second coordinate. Okay, so this way I retrieve these points. After that, initially the apple count will be 0. Then we have to read the frame. So for that you have to use a while loop. Cap dot read give me two things, frame and the read is a bool type, means it will give me the true and false value. If it is false, it means the video is added, and we have to break the loop, while loop. After that we have to read the frame and resize it into the 1280 and 720. After that, what is the use of this mask? Mask is equal to np0 frame shape, means shape of the frame will be the same of the frame which we reading it. Means we not reading, we have but we resize it, and data type it will be unit.8 mask. After that you will see that various mask, it give me this line, this particular line give me this thing, where it is gone. See this one, zeros, black image with the same size of 1280 and 720. After that we will fill poly, it will pass the mask, and the ROI points, the reason which I have blue reason which I have shown you. This is give me this thing, means that that particular reason should be highlighted with white color, and why 255 is used for that only. It give me the, you can say, this way, this gay 1280 with the highlighting the ROI reason with the white color. Okay, then what is the use of this bitwise and? See what is apply bitwise and operation on the frame. First frame, first attribute frame, source image. Frame means second source will be the same image you use again, so pixel value remain unchanged. Using the same image twice make this proportion, like masking we are doing, not comparison. So that and how which we are after that we have to mask, which means reason we have to mask. So we are passing this mask only pixel value where mask is white only we are kept to, we can say bitwise is apply on that reason only. After this line it give me the mask frame. And what is this mask frame? You can see this, it give me this type of frame because we apply only detection on this reason only. We do not require any we do not want to detect apple on entire frame. We want to detect frame means apple on this reason only. So that's why it gave me the mask frame. We will just pass that mask frame into the model.track because we have to track the apple also. That's why we are passing this mask frame. Then the persist true means what is the persist true? Keep tracking ID consistent across frame, but this is a use of this persist true. Then verbose true, verbose will be false. What is the use of this? Disable the console log out, and the zero will be just passing a single frame, means single image we are passing it. So zero days value give me the result of the single image. Then what is it? What is the use of this ROI means function? So here we passing this a frame, then the ROI points, then the blue color means the reason which we get. So let me show you draw ROI function. So this is draw function which we passing the array, then the points means on which reason we have to give the color of that, but give the color that. So how this overlay means frame dot copy. What is the use of this? Create a copy of the original frame. This is done so we can draw the copy. Okay, without permanently this means modifying the original image. That's why we create the copy of that overlay. After that, using the fill poly and color, will fill that particular reason with with that particular color which we passing it. Then you can read it, fill the polygon, define my points on this overlay image and array into the format required by OpenCV. Then after that, add weight is a basically the means the main function which give me the segmented region, or you can say ROI region with color with the transparency, or with blue color with the transparency. So add weight, so you to add weight. If you get if you want to know the more knowledge related to this add weighted, you can go to my channel and see the segmentation, how to develop a segmentation image video. There is a complete video over it. I have explained each in detail way. Okay, so after this line means uh, draw ROI, it's working on, it's not working, draw ROI is not working on a say mask, it's working on a complete frame, this frame. So it's give me this thing, segmentation ROI region with blue color with transparency. Then this draw line. After giving this line points, it just draw the line, it go to the function, this is the points values, it will draw the points, just you use cv line initial points, and the end point it will draw the line and give me, oh okay, see it give me this point with the segmentation and the draw line. So this everything is done. Now come to the main things. We have to just here we pass the model data as oh, we have two times we are doing it, so those here it's not required. So let me erase it. Okay, so it's done here. Then after that, after getting the results, we just have to use we have to iterate over this result dot boxes, then box to get the bounding box details, and use of the center. You can see that here in output we are displaying the center value. Okay, the center value we are displaying it. So how we calculating we are calculating it using the bounding box coordinates values. So that's why we have to iterate over the result of boxes. Then if the box side we here we are using the modular track, so each box has its own ID. So if box ID is none, we will be continuing, otherwise we will store that particular ID in track ID. Okay, after assigning the track ID, you have to assign the x1, y1 and x2, y2 value. X1, y1 is, you can say, the top left coordinates value of the bounding box, and x2, y2 basically the bottom right corner of bounding box coordinates values. And box dot x by given the coordinates value, but all those values in a float format. So we have to convert them into the int, then we have to map them with the x1, y1 and x2, y2. Here row center is basically, you can say, the bounding box center value, and why we are calculating it I will explain you later. Okay, first of all let me show you the calculation how we are performing. When you will explain when you will add x plus x1 and x2 divided by 2, you will get the x center value. When you will y1 plus y2 divided by 2, you will get a y center value. So this way you get a row center value of your bounding box. Okay, then after that we have to get the smooth center. After getting for getting the smooth center and what is the use of the smooth center, I will explain you I will explain the function. First of all, let me show you the parameters which we are passing here. We are passing the track ID for the for one bounding box and the row center. For that particular bounding box, we are passing the row center and the track ID. After that, we will go to the function. Let me explain you. Where is the function? See, here it is a function of get center. Okay, the things which is required by this get center is you can see the center history, and I center history basically contain a particular bounding box or or you can say the particular track ID previous time frame row centers values. Okay, and here we passing it. Here, according to track ID, we are appending the row center of the bounding box for the particular track ID, which store last 10 frame row center for particular track ID. And after that, let me explain you in detail way. Then why we are calculating the smooth center. See, first of all, let me explain you what is the use of this smooth center. Suppose, zoom it. Suppose this, I will take. Let me take this apple, this 249 apple. Okay, I will take this apple for and particular this in current frame. It is here in this green line is here. Green bond, you can say green circle is here. But in next frame, it's come here. But again in next frame, in the third frame, it's go here, and again in fourth frame it's go here. So multiple counting for the for same track ID, but we do not require it. So how to overcome this multiple counting for the same track ID? How to overcome it? For that purpose, I have calculated a smooth center. And how we are working with the smooth center, you can see that for getting the smooth center, first we you can say first we want to extract the x center for means last 10 frame x center, we will extract it here. Same before the y center, we are extracting the y center for the last 10 frame for the particular track ID. After that, we will make the average of it for the average x and average y. Okay, then after that we are passing the average and average y. This is known as the this particular this centers values. This is the known as the average x and average y. Is you can say there's a smooth center or the center values which are displaying here. This thing is basically is the average center for the particular bounding box, or you can say the particular track ID. Let me explain the reason of it, that why we are doing it. The reason is that it's reduce certain jump, which I have explained you that multiple counting will not be there if we use the average center, and make object movement smoother across frame, prevent false line crossing, and increase count accuracy and stability. That's why I've used this average center. Okay. Hope you understand better that why we are calculating this get smooth center, or why we are using this center history. Why we are using the center history for the for the average calculation. Okay. Now let me explain you another thing. That after getting the smooth center value, if the track ID, let me explain the previous center. Previous center basically you can say where it is gone. See here, previous center. Previous center basically store the particular track ID previous frame center value. Okay, previous center track ID. You can say if a track ID is in previous center and a track ID not in a counted ID, then we will say that particular track ID is not counted. So we have to move to inside the if loop. Like let me show you the this is, you can say, the line which make you more clear what is the use of this if statement here. Check if the object exists in the previous frame. Yes, it is exit. If it is exit, needed to compare movement across the frame. So that's why if it is in a previous center and track ID not in a counted ID, then we will say that that particular track ID is not counted. So we will move inside the if statement. Then how we can check that particular track ID is past the line or not. Okay, so how we can do that? For that purpose, we use in center crossing line function. Here we passing the previous center track ID, center position in previous frame. Okay, means center position in the previous frame. What is the center position of the previous frame? Okay, and then smooth center, which we have calculated above here. Then the line points 0, starting points of downline, and starting points ending point of a downline. Okay, so these are the coordinates value which we pass. Let me explain you here. So this is a function which we are using it, which help us that particular track ID has passed the line or not. Okay, you can say this is a previous center. Using the previous center, we will extract the previous position of the particular track ID, and the current position of the track ID is like this smooth center which we have calculated. Okay, after that, this is line one, line point one, and line point two. After that, what is the calculation going on? Let me explain you here. Above in the function, as you can see, we get a previous and previous line point one and previous line point two. Just these are the examples. Previous center, then the current center. After calculation of all things, what is happening here? See this. This is a calculation x2 minus x1 into py minus y1 minus y2 minus y1. So this is a calculation of previous side and a current side. If the previous side calculation is done, this is a previous side calculation. Compute which side of the line the previous center lies on. Okay. And here, after current side, compute which side of the line the current center lies on. Okay. If both previous side and current side is both are opposite, okay, or less than 0, it means we have crossed it. Otherwise, we have not crossed it. So this is the reason that this calculation is going on here. If we multiply both and it is less than 0, then we will say that the particular object has crossed the line. Otherwise, we will say it has not crossed the line. So this is a calculation which is helpful for me to that previous in a previous what is the position of the particular track ID at the previous frame, and what is the position of the particular track ID at the current uh, not position, side, which side of the particular track ID is it, whether it is in a uh, whether it is in this side or whether it is in a this sides. Okay, so this way it helped me for the calculation. After getting this previous side and current side, if it multiplication is less than 0, we can say that is it has crossed the, otherwise it is not crossed the line. So this way we can do the calculation for the track ID that it is had crossed the line or not. After getting the calculation, if it is true, it means it has crossed the line. So we have to update something. So what do we have to update? Apple count will be increased by 1. And second thing, in counted ID, we have to pass the track ID that particular track ID has already passed the line. After that, we have to update the previous center. We have to update according to track ID. We have to update the smooth center here. I already told you that previous center basically store the particular track ID previous center position or smooth center values, which help in that particular track ID has crossed the line or not, or in some calculation. Okay, then we have to display the color. You already know that you already have seen that the circle after passing the line, its color will be become to red. So how we can do that? It's very simple. If the track ID is not in a counted ID, if the track ID is not in a counted ID, the color will be this only, will be green, and as soon as it passed the line, its color become red. So this is a color selection which we have done by the if statement, and using this simple counted ID, you can say dictionary. Then we have to display the circle. The circle, for circle we display, we use cb circle. Then we are passing the frame. Then the smooth center. Okay, we have to display this smooth center. This I already told you. I already told you that this is not a row center. It is a smooth center which we are displaying here. Okay, then the thickness, you can see the thickness, and the -1 will be particular fill. 5 is basically radius, color, and -1 means we have to fill that particular circle. Then we have to put a text. The text which we want to display is track ID. So frame, we have to pass a track ID in a string format. Then the position of this text. So how we have decided it? Just very simple. Smooth center plus x plus 5 means it will be, towards the right side, and smooth center -1. This way we decide the positions value for the display of the text track ID. Then this is the font. 0.1 is the thickness, color. Then the scale. 0.7 is the scale, and 2 is the thickness. Okay, so this way we display the text. Now, save to rectangle means we have to display the rectangle. Where we have to draw the rectangle? It's So here we are drawing rectangle, and over the rectangle we are displaying the counter. So first we have to draw the rectangle, then we have to display the counter, and just we have to show the frame. Then use of this CB2 wait key, it will, just soon as I press Q, it will break the loop automatically. Then I have to clean up, or you can say release the memory. So this is up. Now let me run this code. Okay. Wait for the seconds, it will run. You can see. Okay, it's working very well. Here it is moving very slowly because my GPU is not very good. Okay. Now let me explain you what we have done in here. Okay, so first we have to extract the first frame of the video. Then we have to make the train and test folder. Then we have to okay, after that we have to use a data augmentation using a data augmentation, or you can say generator p.py file. We have generated a 600 images for using a single frame. We have generated 600 frame with the bounding boxes. Then after that we have to make the zip file. We have to upload that zip file to the Google Drive. After that we have to train using a Jupyter file. We have to train that particular model, using YOLO model. Then we have to download that particular model. After downloading the particular model, we have to use the main.py file to count the apple. And I have explained the each function. What is the use of previous center? What is the use of counted IDs? What is the use of this those dictionaries? What is the use of how we're developing this ROI reason? Okay, so I have explained each and everything. Now let me show you one output video. Okay, so here it is working very well. There also it's working very well, but say it's you can say I have saved the video for you. Okay, so see, it's working very well. Okay, so if you want more videos like this where I've explained you each and every line with detailed way, so please like, share and subscribe my channel. Thanks to all.